This is base 3 logarithm. So do it once. Part A is saying use base 10, and part B is saying use the natural log. So they want you to do a base change on this using base 10 and base E. Do that now. So for that first one, if you wrote log base 10, that's fine. Some of you might skip writing the 10 in there because it's a common logarithm. Just write logarithm. Put the x on top, base 3 on the bottom. If you were doing ln's, which is the lazy boy way of doing it, a couple less letters, ln of x, ln of 3. Now we're actually going to work on solving some of these equations. So, in this first one, we have log base 2 of x raised to the second power is equal to 16. What's the first thing we have to get rid of? My x is inside the parentheses, so I need to get rid of that square. So I'm going to square root. So I have log base 2 of x equals, what's square root of 16? 4, but I have to put the plus or minus in, because I took away the even power. Right? The even power of 2 is there. We took it away, plus or minus. Now what are you going to do? Anytime you feel a little bit stuck, we're going to get out of the logarithm form into exponential form. Or get out of exponential form and write in logarithm form. So switch. So logarithm base 2 is my exponential base 2. We say that logarithms are always equal to the exponent. So I have plus or minus 4, and that's equal to x. I just went from log form to exponential form. Okay, here we go. So one time we do this, we're going x equals 2 to the 4th. Another time we're going x equals 2 to the negative 4th. What are my answers? What's 2 to the 4th? What? 2 to the 4th?
16.
16. What's 2 to the negative 4th? 1 over 16. So those are my two answers. We should take those and plug them back in to make sure it works. What's 2? 2 to what power gives me 16? That's a 4. 4 squared is 16. Plug in 1 over 16. 2 to what power gives me 1 over 16. Negative 4. Negative 4 squared is also 16. So it works. What are you going to do in part B? I would just write it in exponential form. What's my base? Logarithms are always equal to what? The exponent. So 16 is my exponent. So what is 2 to the 16th power? What? I believe it's 65,536. So what do we have to do to solve it? Square root. So I get x is equal to plus or minus, what's the square root of 65,536? So I have x equals 256, and I have x equals negative 256. Right? We have two answers there. Let's plug them back in to make sure they work. Well, when you plug in 256 and you square it, 2 to the 16th power gives me that one. If I put in the negative, is that working? Yes, because I square it first and then I say 2 to the 16th will be that number also. So what's going to start happening in this lecture and the next couple is you guys will start to feel a little bit like, I know what I'm doing in this class, but I don't know how to start the problems. So for those of you, when you got to the last test back, think about, I knew what was going on, but did I know how to do every problem? So the repetition, you may have to go in the textbook and do some extra problems. When you look at a problem like this, I have two logarithms. What I want you to do is squish them together. So I have 1 log base 5. What do I do when we're adding logarithms together? How do you squish them back together? What are we multiplying? X minus 3 times x plus 3. So I'm going to save a little bit. So what we have is log base 5. X times x is x squared. Negative 3 times 3 is negative 9. And there's no middle term to it, right? Because the positive 3x and negative 3x cancel out. What do we do? Rewrite it in exponential form. So I heard 5 to the 4th equals x squared minus 9. So 5 to the 4th equals x squared minus 9. Let's add 9 on both sides. What is 5 to the 4th power minus 9? What did I say? I said minus. 5 to the 4th is
634.
Well, 625, and then adding 9 is 634, right? So what do we do here? So if I square root, I get x equals plus or minus. Is that a nice number?
No.
No. Let's just do 634 then. So x equals the square root of 634, and x equals the negative square root of 634. You can barely see them, but I got it on it. What happens when you take the negative square root? What is square root of 634? It's approximately 25 and some change there, but so take the negative about 25. What's negative 25 minus 3? Negative 28. What's negative 25 plus 3? Oh, negative 22. But in both cases, we're trying to take the logarithm of a negative number, right? Can you do that? No. So let's get rid of that number. So the negative one is not going to work. And I know that because when I plug it back in, it won't check. Okay? Part D, you actually ran into one of these on your worksheet already. Couple of different ways we can do this. But for now, what they want you to do is work in like bases. So, 3 to the 2x is equal to 3 to the what power? 243. How many 3's do you have to line up to get to 243? 3 squared is 9. 3 cubed is 27. 3 to the 4th power is 81. 3 to the 5th power is 243. Now, you attack this problem knowing I'm going to try to get the bases the same. And if you go 3 times 3 times 3 times 3 and you skip over 243, then you have to handle it what we teach you tomorrow. But for today, if you can get the bases to be the same, it's a lot easier. Because if the bases are the same, what do you know about the exponents? They have to be the same. It's kind of the one-to-one property, right? There's an equal sign. Left is the same as the right. So all I have to do is take 2x is equal to 5, divide by 2, X is 5/2. You can go back and check this. Type in 3 caret parentheses 2.5 times 2. I guess I should have written it 2 times 2.5, but right? Working? Okay. Oh, is this the last one? Oh, this is okay. Here we go. Let me pause it. I'm gonna stop it. New video. That next one.